As a third example, we will discuss this one. Let x and y be independent exponential distributed random variables with parameters lambda and mu respectively. Define capital U, that is nothing but minimum of x comma y, and V is nothing but maximum of the random variables x comma y. The third random variable capital N, that is defined as, it takes a value 0 if x is less than or equal to y, it takes a value 1 if x is greater than y. So, using the two random variables x and y, we have defined three random variables u, v and n. Our interest is to find the probability of capital N takes a value 0 and what is the probability of capital N takes a value 1. Fine. The second, we are interested to find out the probability of N takes the value 0 and capital U takes a value greater than some t, where t is greater than 0. So, let us go for finding the second one first, then we will find out the probability of x equal n equal to 0 and the probability of n is equal to 1. So, let us start with the 2 first. The event n is equal to 0 and capital U takes a value greater than t, that is exactly the event of t less than capital X less than or equal to capital Y. The event n is equal to 0 and capital U greater than t, that is same as t less than x less than or equal to y. Therefore, the probability of finding n takes a value 0 and u takes a value greater than t, that is same as probability of x takes the value t less than x less than or equal to y. That is same as the double integration with the t less than x less than or equal to y of the joint probability density function of x and y. Since x and y are independent random variable, the joint probability density function is a product of marginal probability, this is e power minus mu y dy dx. So, the probability of t less than x less than or equal to y, that is same as the double integration t less than x less than or equal to y of integrand is lambda times e power minus lambda x mu times e power minus mu y dy dx. That is same as the inner integral becomes x to infinity mu times e power minus mu y dy, then lambda times e power minus lambda x integration with respect to x between the limits t to infinity. That is same as now the inner integration you can integrate and you can substitute the limit x and infinity. If you simplify, you will get t to infinity e power minus mu x, then multiplied by lambda times e power minus lambda x dx. If you do the integration, the interior integration, you will get e power minus mu x, then the remaining things are as it is. That is same as you can keep lambda by lambda plus mu outside. This becomes integration from t to infinity of lambda plus mu times e power minus lambda plus mu x dx. You know how to do the integration for this. If you simplify, you will get the answer, that is lambda divided by lambda plus mu times e power minus lambda plus mu times t. So, this is the result for probability of n takes a value 0 and u takes a value greater than t, where t is greater than 0. Similarly, you can work out the probability of n takes a value 1 and u takes a value greater than t. That will be mu divided by lambda plus mu multiplied by e power minus lambda plus mu times t. So, with this the second part is over. Now, we have found the probability of n is equal to 0 and u greater than t. Also, we got the probability of n is equal to 1 and u greater than t. Now, we will go for finding the first result. But before that, you can find what is the probability of u greater than t also. That is nothing but finding out the probability of n is equal to 0 and u greater than t plus the probability of n takes a value 1 and u greater than t. That is the way you can find out the probability of u greater than t. You know the result. If you add, you will get the result, that is e power minus lambda plus mu times t. That is the meaning of the minimum of two random variable takes a value greater than t, that is e power minus lambda plus mu times t. We can find out the probability of n is equal to 0 in using probability of n is equal to 0 and u is greater than 0. The t is greater than or equal to 0, therefore, probability of n is equal to 0, that you can compute from probability of n is equal to 0 and u is greater than 0. That means, you substitute t equal to 0 in the previous result, you will get a probability of n is equal to 0. So, that is nothing but, if you recall, probability of n is equal to 0 and u greater than t, that is lambda divided by lambda plus mu e power minus lambda plus mu t. Here the t can be greater than or equal to 0. So, substitute t equal to 0, that will give probability of n is equal to 0. Therefore, this will become lambda divided by lambda plus mu. Similarly, you can find out the probability of n is equal to 1 in probability of n is equal to 0 and probability of n is equal to 1 and u is greater than 0, or you can find out probability of n is equal to 1 by making 1 of a probability of n is equal to 1 minus probability of n is equal to 0. So, two ways you can find the probability of n is equal to 1. So, here I am using 1 minus probability of n is equal to 0, that will be mu divided by lambda plus mu. So, in this problem, even though we asked only two things, but here we have got probability of n is equal to 0, probability of n is equal to 1, also probability of u is greater than t. If you observe probability of n is equal to 0 and u greater than t, that is same as probability of n is equal to 0 multiplied by probability of u greater than t. Similarly, we will get the observation probability of n is equal to 1 and u greater than t, that will give probability of n is equal to 1 multiplied by probability of u greater than t. So, hence n and u are independent random variables. So, this example is useful in birth death processes. Therefore, I am explaining this problem as a illustrative example.